Space. Infinite. Beautiful.
Mystérieux.
We've traveled just a whisper's width into its vastness. We've walked on the moon.
Sans robot to Mars.
Watched distant galaxies through powerful lenses. But to truly explore space, beyond the stars across. In the 1930s, astronomers like Fritz Zwicky noticed something strange. Galaxies were spinning so fast that, by all logic, they should have torn themselves apart. But they didn't. Something invisible was holding them together. Some unseen glue with mass and gravity, but no light. That something became known as dark matter. Today, we believe that 85% of all the matter in the universe is dark matter. Ordinary stuff, the stars, planets, even us, make up just 15%. Imagine trying to sail a ship, not knowing that there's a strong wind pushing your sails, because you can't see it. That's us. Navigating space, without fully understanding what most of it is made of. And here's where it gets interesting for space travel. When we think about space travel, we imagine engines, thrust, fuel, maybe even exotic warp drives that bend space-time. But all of these things rely on our understanding of mass, energy, and gravity. Dark matter affects all three. Let me explain. We used to think gravity was simple. The more mass something has, the more it pulls. But dark matter distorts this equation. It's invisible mass that shapes the gravity of entire galaxies. And if we don't understand how that gravity works, how it pulls, how it bends space-time, we can't accurately chart our journeys. Some scientists think that what we call dark matter might not be matter at all. Maybe gravity behaves differently at large scales. Maybe we're missing a deeper law of physics. Either way, if you want to cross a galaxy, you'd better understand the gravitational ocean you're sailing through. Here's a wild idea. What if we could harvest dark matter? Some theories suggest that dark matter particles, like hypothetical WIMPs or axions, might interact in subtle ways we can one day tap into. If we could build a reactor that captures and converts dark matter into usable energy, suddenly, the vast darkness between stars becomes a resource, not an obstacle. This isn't science fiction, it's speculative science. There are already experimental designs for dark matter detectors floating deep underground and in orbit. If we ever crack the code, dark matter might power our future interstellar engines. Dark matter doesn't just sit around.
It forme massive structure, like un invisible skeleton of the universe.
Galaxies gather along these threads of dark matter, creating the cosmic web. If we learn how to map it in detail, it could be the ultimate GPS for deep space navigation. Instead of getting lost in the void, we could use the dark matter grid as celestial highways, guiding our spacecraft through the most efficient routes, much like ancient sailors used trade winds. Right now, the speed of light is our ultimate barrier. But dark matter, and its elusive cousin dark energy, may hold the keys to understanding the deeper structure of reality. Theoretically, if we understood how to manipulate the fabric of space itself, to compress or expand it, we might create warp bubbles or shortcuts through spacetime. And that fabric? It's influenced by dark matter. It's as if we're trying to build tunnels through mountains we haven't yet mapped.
Every leap in space exploration started with a deeper understanding of the universe.
When Newton discovered gravity, we got orbits.
When Einstein redefined gravity, we got GPS.
When we understand dark matter, we might get something far bigger, the ability to shape space itself. We can't explore the cosmos with 15% of the map. Understanding dark matter is not just a physics problem, it's the next evolution of our destiny. So, what does dark matter have to do with space travel? Everything. It holds our galaxies together.
It warps the space we travel through.
It could fuel our ships, guide our routes, and reveal shortcuts across the stars. It's not just a question of what it is. It's a question of what we can become once we understand it.